Moving on, our next speaker has been part of numerous operations focusing on drilling, well control and data acquisition offshore Norway. She's provided valuable contributions to the development of Exebenus Pulse product and to the company's journey providing digitalization and automation of drilling operations. So will you please welcome Serafima Schaefer.
Thank you. Thank you too. Good afternoon, ladies and gentlemen. My name is Serafima Schaefer. I'm a well digitalization manager with Exebenus, and I have been working offshore for several years for main oilfield service companies in the Norwegian North Sea, as mentioned before, and had the chance to see a number of operations. And during my work, some of my responsibilities included to monitor the sensor data on the rig in order to validate that whatever plan that was made for the operations, it was executed successfully and that the operations are going according to the plan. So it makes me quite excited today to introduce you Exebenus Pulse, because whatever I was doing manually, part of this job is actually possible to do digitally today. So Exebenus Pulse, it's a software solution that generates detailed digital operating procedures for drilling, completion, and other operations. And these procedures during execution could be connected to the real-time stream, and then based on this, the sensor response, it could be validated if the operations are completed in time, if they're going according to the plan, or if there's any deviations happening. And also, because the procedures are digital, they're not only human readable, but they're also machine readable. And so as such, they can become the first step on your digitalization and automation journey. So just a couple of words about Exebenus history. The company was started in 2014, and after a few years of evaluating the ideas, the development was started. The commercial product was released in 2019 and is used by several clients. And in 2020, Sumitomo decided to invest in Exebenus because they believe that the work that is done in our company, it supports their vision on future for the autonomous drilling. So, but getting back to the subject, when I talk about digital operation procedures, there are many names that you could use. It could be called standard operating procedure, rig action plan, detailed operation procedure, standing instructions for the driller, and so on, so on. But whatever you call it, it is a procedure that you spend considerable time preparing so that the rig crew can execute the operation with success and with as few challenges and surprises as possible. And you also want to make sure that the operation is executed in a safe manner and using the company's best practices. But if you look at the procedure, how it is done today, it is usually in a text format, which is could be edited in Excel, Word, or PDF. And the information in the procedure, it comes from and depends on various sources. It could be well information, risk register, equipment technical limitations, lessons learned and best practice library. There's also different types of information in the library. So here I have highlighted it in the colors. But whenever I was working offshore, you know, I had to find out those parameters, for example, that I have to watch, because it wasn't really structured. So if you look at the way how the procedure is, it is now, it has, first of all, it is lacking common language, so it makes it difficult to interpret. It is lacking consistency, which increases the risk of miscommunication and misunderstanding. It is lacking standardization, so the procedure is actually quite dependent on the person who prepared the procedure. It could be too detailed or less detailed, and it's lacking the possibility for automation. And here, when I say automation, I mean not only rig automation, but any other form of digitalization. For example, if you want to use sensor data to track the execution of your activities, or if you want to import your activities further into the daily drilling report. And finally, the way how the procedure looks now, it is time consuming to prepare it and to update the procedure, and prevents the operation to proceed in the most swift and safe way as needed. So all these things were the reasons why we have started Exebenus Pulse. And our fundamental point was that we wanted it to be easy and simple to work on the procedures at any given moment. So let me show how it could be. This is an example of a similar procedure. which is how it looks in Exebenus Pulse. You can see it could be quite structured, and I will go more into the details, but the activities, parameters, risks and lessons learned available at any given point. You could see that, with Exebenus Pulse, you can create, validate digital operating procedures, which are easy to make and easy to update during operation. It leverages the best practices and lessons learned. And with its help, you can validate, automate, and track operation with a real-time data feed that it comes in. So let me just show you how it actually works. So right now you can see Exebenus Pulse in front of you, and you can see that this is it's a 17.5-inch drilling procedure, which consists of several parts. So first I will go into the overview to give you the background of this procedure. Each procedure has its own context. It has a wellbore, rig associated with this, section size, and other information. This context is very important because this context is the one that would influence your risks, best practices, lessons learned, and checks included in the procedure. That's what makes it dynamic, and I can show you how it works just in a minute. Then there is a pre-operation part where you would usually include pre-operational checks that are needed for each procedure to be executed. But let's look into the operation. So the procedure itself, on the left side, you can see the major procedure steps that are included: pre-job safety meeting, making up an equipment. So you could easily navigate between the different parts. For example, if you need to rearrange the procedure steps, that's possible to do. If you would like to go to a certain step and to see more of the details, you could just easily navigate to that step. And each procedure step would have usually some number of activities or sub-activities included in that. So here you could see there is the activity, the parameters associated with this, and the relevant risks, checks, lessons learned, and best practices that are following this. So let me show how you can add a procedure step. For example, in this procedure, you would like to make sure that we're loading the radioactive source in the tool. Here you could see that it usually consists of a couple of smaller activities, which is a pre-job safety meeting and installing the radioactive source itself. It doesn't have any parameters associated with that, but it has a risk and a check associated with this procedure step. And what is important for this risk. You could see it is quite a specific risk. It is targeted on this equipment that is used, the tool where you load in the radioactive source, and it's only valid if it's a 17.5-inch hole section that you work in it. So if we look more into the details, with the help of certain assignment options, you can actually target your risks, best practices quite detailedly. So for example, if it was some other hole size, your risk wouldn't be shown. If it was a different equipment, it wouldn't be displayed in this procedure. So it will be only available in the library for the reference of the drilling engineers. This is how the procedure you look when you work on it in the draft mode. And of course, there is a collaboration function so that you can discuss certain parts of the certain issues about the procedures. There is a notification panel. If also there is a need to reference, there is a drill string and the wellbore that the engineers could look. So so now you had a chance the first part was you had a chance to look at how you build the procedure. After you have built your procedure and you have worked on it in a draft mode and you think it's in a good enough condition, there is an approval process that leads to that the procedure becomes into the approved state. After that, when this procedure is approved, usually it goes on the rig to be executed. So I would like to show you how you could how the procedure would look during the execution part. So here you can see it's a procedure consisting of, again, of the several activities, and it's already in the approved state. The activities they could come in a different there are different types of activities. Some, for example, the first one, which is called drop to, and of course it shouldn't say drop to here, it should say drop all. I've just included it to make sure that you are still following my conversation. It's a manual activity, meaning that there is no response that it would trigger, and there's quite a lot of activities like that on the rig. You know, when you do something and you just it's not possible to validate with the sensor if this activity is happening or not. But then the next activities that happen, you know, since the procedure could be connected to the real-time WITSML feed, it's possible to actually validate that whatever you are executing, it's going according to the plan. And I will show you how it works just in a minute. So, and also for the sake of the demo, the real-time feed is speed up 100 times. So please, note that the demo could be a little bit fast as it goes. Yeah. So in front of you, you could see this is an approved procedure, which has a procedure step and a check associated with that the driller could check during the execution. So let me start the first activity. Yeah, and you can see that the procedure status has changed to the active. The clock has started to tick. So if I stop this activity, it goes to the next procedure step. So, and then you can see the start and end and the duration of this activity. The next displays part, it's an automatic activity. So what is expected here is that first the flow rate should have been increased to 1,300 liters per minute. And then the flow rate should have been, we should circulate for 60 minutes in a row. And you could see that there is at the bottom there, that's the actual parameters that come in from the WITSML stream. So first, the flow rate is increased to 1,330 liters per minute. And the system validates that this is okay. It resets, like validates that it is the correct increase, because that's how the tolerances has been set up in the system. But the next step, when the circulation should last for 60 minutes, actual time of this circulation is only 55. That's why the system puts a yellow mark and validates that there is some deviation. In the next step, the flow rate was supposed to be decreased to 350 liters per minute, but it was decreased to 315 liters per minute. And that's why the system validates that there is some deviation from the plan that was made. So that's how it goes. And you could see that all the steps, the system can validate that it works. And when it's finished, the procedure turns into the as-run state. So with the help of Exebenus Pulse, also in the end, you could analyze how the procedure was, if it was done according to the plan, if there were deviations, what were the start and end times of the operations, and all other relevant information. This is how the procedure would look, you know, if you want to follow the operations in the office or in the real-time center. But if you wondering how it could look in the driller's cabin, there's also a possibility to have the same functionality on the tablet. So you could again start the procedures, skip certain steps, for example, or add a new function on the go. So I guess as the time is running out, to come to the conclusion, I would like to say that Exebenus Pulse helps you to automatically generate digital operating procedures that are easy to make and easy to update. So that saves your time and increases the efficiency of your operations. It is easy to understand and to act on. So we're introducing consistency and standardization in the procedures. It warns you if there's any deviations from the plan in the real time, and it helps you to eliminate the risks and to make sure that it stays within your safe operating window. And lastly, if automation is part of your company's ambition, Exebenus Pulse is the first step to this goal. As the procedures, they're not only human readable, as you have seen, but also machine readable, and they are ready to integrate with the rig control system. In conclusion, Exebenus Pulse solution gives you confidence to safely execute and optimize rig operation. And the overall power of Exebenus Pulse digital procedures is that it helps you to streamline your operations and increase your productivity by reducing NPT and ILT. Thank you for your attention.
Thank you, Serafima. And with 1 minute to spare, I reckon that was a perfect timekeeping on your behalf. And for you sitting out there listening, I hope you got a good understanding of how this Exebenus Pulse can make your procedures truly digital, dynamic, and easy to update and easy to validate. So ensuring that you get an optimized rig operation and potential cost savings of your drilling process. So thank you, Serafima.
Thank you, and looking forward to the questions.
For you, Serafima, from Carlos, how do you identify from which XML feed which operation is performed? That's a two-part question. How do you access procedures when there is a problem, like stuck pipe?
Yep. Thank you, Carlos, for the question. So for the first question is, you know, with Exebenus Pulse, you can create a detailed digital operation procedure. So you create a plan of action, what is planned to be executed. So at any given moment, you actually know where you are and what is happening, at which stage you are. You also would know the context of the operation that you're executing. You would know the parameters that are happening. So for example, if you are going to circulate and it's planned that you're going to circulate with 600 liters per minute, you would know which response it should trigger in the sensors. And so that way, so when the WITSML stream is connected, you actually already know what is to expect. So the system just validates that the response coming from the sensors is according to what is happening. And it makes it different from the you know, a state detection, because then you don't really know the context, what is supposed to happen. While with the Exebenus Pulse digital procedures, you have the idea where you are and what are you doing. And it becomes especially important, you know, for non-drilling operations, for example, setting liner hanger, when there is a specific of how you set a certain tool and the sequence of activities depends on the equipment itself. So that's the first part of the question. And the second part is how to access procedures when there is a problem. We do support that during the planning stage to each procedure step. You can, first of all, you can just attach a contingency for procedure if you know that there is one that could be valid for that operation. And it's possible also to do that a certain operation, you could attach a risk. For example, stuck pipe would be a risk associated for maybe for this section and the formation that you're drilling through. And then with this, through this risk, you could also attach the contingency procedure you would like to switch to if this risk is taking place. We also do support if you don't have maybe a specific procedure for a problem, but just some sort of guidelines how to handle that. We do also support attaching the best practice to any of the procedure at any given moment. I hope that answers both of the questions.
Great, thank you, Serafima. So with that, I'd like to leave you all and say thank you for participating today, and thank you for your interaction, and have a great afternoon. Bye-bye.